sympathetic chain and how the body is going to communicate within the sympathetic chain. So as an overview, obviously we can get a lot more in depth, but the sympathetic chain runs from the base of the skull all the way down to the coccyx. However, the sympathetic information, that lateral horn, is only available from the levels of about T1 to L2. And that's going to come into play later on in this. So we know that sympathetic comes out innervation is the lateral horn from T1 to L2. It passes through that anterior root, just like the somatic efferents would be doing. And then as it comes down, it moves through and synapses, or potentially doesn't, we'll talk about it, but it moves into the sympathetic chain. The sympathetic chain runs anterior to the vertebral bodies. And so once it's in there, there's 3 different things that it can do. So let's say 3 options. Number 1 is the most basic. It can synapse at that level. So what we'll say with the one that we're drawing right now is that the yellow is the first neuron in a 2-neuron chain for sympathetics. It synapses in the sympathetic chain at that same level. And then that comes out and goes into the body to the target areas. That's number 1. Number 2 is it can ascend or descend before it synapses. So if you think about it, the sympathetic chain over here from more of an anterior view, there'd be a collection of these beads kind of all hanging out. And so what can happen is the first neuron can exit a spinal level, enter in via the rami communicans, this little bad boy here, and then it might ascend. So say it's started at T1 or T2 and it's ascending all the way up to go and have an effect on the upper cervical sympathetics. Or it can descend, so say it's at the level of L2 and it's going down to provide innervation down in the lumbar, down in the sacral area. So it can ascend or it can descend. The third option is it can not synapse. And these ones then become our splanchnic nerves. So the splanchnic nerves, I'm going to draw it in, I don't know, whatever color this is. Come out, they still go through, but they just kind of loop and they're like, no, I'm not stopping there. And they keep going. And then they synapse somewhere else at a plexus closer to the target organ, right? Remember, splanchnic nerves go to organs. And so they synapse, they're still a 2-neuron chain, but they synapse somewhere closer to the organs. So that's where you get parasympathetic and sympathetic innervation kind of intermingling. Now, why would they do that? Why would we need splanchnic nerves not to synapse here, but to decide to just go straight to the organs or closer to the organs? Well, with the 2-neuron chain, the first neuron is myelinated. Right? Myelination equals very fast. The second neuron isn't myelinated. So if I could run as fast as that, I'd still be real happy, but it's not as fast as a myelinated neuron. Meaning that if you want to get information as fast as possible to the organs, which obviously sympathetic is a quick response, a fight or flight response, then you want to make sure you're sending it via as much fast myelinated neuron as possible. So those are the three options. It comes out of the lateral horn, T1 to L2. It can either synapse at that level in the sympathetic chain, in which case the second neuron cell body is in the sympathetic chain and leaves at that level. It can ascend or it can descend if necessary. So that's why we can get information from, say, T1 to T9 or T10 to L2 having effect on the upper and lower limbs respectively. Or it cannot synapse at the sympathetic chain, and those would be our splanchnic nerves. And the reason is because we want to have that myelination as far as possible, getting towards the target organ.